I will start by opening up more of what I have in this bracket. That is to say, I will start by expanding the bracket. So to do that, I have 4 already, open bracket. This is 3 to the power of x times 3 to the power of 1. I hope you know that, but because the power 1 is not written, I'm going to keep it just that way. Have that in mind, it's going to help you a lot. And the next one is exactly the same thing as 3 to the power of x everything times 2, right? This is x times 2 is 2x. I'm trying to make it easy for myself, and then you come to see how this turns to a quadratic equation. Everything equals 27. Now that we have reached this level, watch what I'm going to do. I'm opening up this bracket just this way. 4 times 3 times 3 to the power of x minus, are you following this? To square this number simply means 3 to the power of x times 3 to the power of x, right? So you can leave it the way it is or you can square it. It's your choice. All is equal to 27. The most important thing is you know the direction you are going to. Now watch. There is a thorn in the flesh, 3 to the power of x, which appears everywhere. So let us substitute any letter for it. So in this case, let us use let the letter y be the same thing as 3 to the power of x. This is very important, so you keep it safe. You're going to use it later, okay? If this is the case, any place we see 3x, let us put the value y. Now, 4 times 3 is 12, and 3 to the power of x will now become y. Minus y times y is equal to 27. Okay, I think this is going to help us. Therefore, at this stage, we have 12y minus y squared is equal to 27. This is a quadratic equation. So, let us arrange it properly and solve exactly the way it should be. We'll get our answer. Multiply everything with a negative 1. That gives us y squared minus 12y is equal to negative 27. Equating everything to 0, I'm going to come this way to make this happen. So, to make it work out, to look exactly like the normal quadratic equation, I'm going to bring 27 to the left hand side. So I'll have right now y squared minus 12y minus, no, it's going to be plus 27 is equal to 0. All right. Can we solve this problem using factorization method? Yes, we can do that. Because I can simply express this as y squared minus 9y minus 3y plus 27 is equal to 0. At least 3 plus 9 is 12, so it works. So let's factorize. Y times y is y squared, y times 9 is 9y. Okay, let's work it this side out. Minus 3 times y is 3y. Minus times minus is plus, so 3 times 9 is 27. Everything is still equal to 0. So since we already have our brackets same, let's factorize further. So we have y minus 9 in one bracket and y minus 3 in another bracket. All is equated to 0. So if you find the values of y, you end up having y is equal to 3 or y is equal to 9. So using the values y equal to 3 and y equal to 9, we are going to solve y is equal to 3 to the power of x. Don't forget that. So remember we already said that y is equal to 3 to the power of x. But in this case, we found the values of y to be y is either 3 or 9, right? So what will be our value of x? To make this happen, in place of y, we write 3 to the power of x because we already substituted y for 3x. So we're bringing it back. Hence, we're going to say when we have a case of y equal to 3, it happens to be that 3 to the power of x will be the same thing as 3. And when we have a case of y equal to 9, we replace y with 3x to mean that 3x will be equal to 9. So let's solve this out. In this case, if we cancel out the powers, if we cancel out the bases, we're left with just 1 at the power here. So x will be equal to 1 on this side, and on this side, 3 to the power of x is equal to 3 squared, because 3 squared gives us 9. Therefore, we can confidently say that the values of x are 1 and what? Here we cancel this out and we cancel this out. It's going to be 2. So s is equal to 1 and x is equal to 2. So the values of x are 1 and 2. Or you can just say 1 and 2 like this. Now you see we've ended up solving this problem successfully where an indices leads us to quadratic equation. I hope you enjoyed today's video. Please give us a like, comment, and let us know what you enjoyed most about it.